Okay, hello. We will take a look at a stoichiometry problem. Stoichiometry seems to trip up a lot of chemistry students. So this is a nice limiting reagent. Determine how many grams of Ag are produced if we use 5 grams of copper, 1 gram of silver nitrate, excuse me. So there are two ways to solve this. The first way that I tend to do is just like you use both values and then like you do like the usual stoichiometry stuff to figure out the amount of product produced, and then you use the smaller value because that would be like from the limiting reagent. So we'll start, this can be using copper and this can be using AgNO3. So I'll just draw these little brackets. So the first thing I always do is start with what you want to solve for. So grams of Ag, we are given grams of Ag, or the molar mass. I don't know if your teachers would give you that, but it's just a waste of time. Like you know how to calculate that. And then now we have this. We're trying to get rid of this mole Ag. How can we get rid of 1 mole Ag? We can use like the molar ratio. So this is 2 moles Ag, excuse me, and then 1 mole copper. And now how to get rid of this 1 mole copper? Well, we know the molar mass, which is 6355 GCU. And how do we get rid of this GCU, grams copper? Oh, well, we know this value, so 500 grams copper. And a nice little gut check is if we can cancel out these units, and the final unit should be Ag, grams silver. So if we cross out GCU, mole Cu, mole Ag, we get G grams silver, and the number is 16.97, which I calculated ahead of time. And then we're just going to run this exactly back, but instead of using copper, we will use silver nitrate. Again, how do we get rid of this mole? We use that molar ratio, 2 mole Ag, except this time we have 2 mole AgNO3. To get rid of this mole AgNO3. I'm really sorry about this handwriting. I'm trying to do better. I just got this little tablet, so hopefully it'll improve. GAgNO3. And then finally we use our value that we know, which is 1.00 G and AgNO3. And this comes out to be 0.63 gram Ag. So we have our two values that we've computed using the two different reactants. Compare the smaller value is your answer. So the answer is 0.63 G Ag produced. And then the limiting reagent is just whatever you used to make that. So copper made the big guy, AgNO3 made the small guy. So the limiting reagent is AgNO3. And there you have it. That is exactly how you solve this problem. This problem did not ask you to state the limiting reagent. Sometimes it will, sometimes it won't, but this is how you do it. There is another quick way that I'll show you to solve the limiting reagent. It's a little bit less intuitive, which is why it was not the first thing I showed, but some YouTube people show that, and so I didn't want to leave folks out of that knowledge. So a second way is just this is a two-step kind of solution. So first you determine LR. In that problem, we determined LR kind of at the very end. The first step you do here is you determine LR by calculating what I like to term the relative, I guess, molar amount. So we're given that we have 5 grams of copper, so let's just calculate the relative molarity. So this has 1 mole. So the number of moles of copper that we have is 0.078 moles. And now when we do, I'll just write copper. And now we'll do LR. Oops, just get rid of that one. We don't know that yet. And then we have 1.0 G AgNO3. This is terribly messy. And then we have our molar mass. G AgNO3 corresponds to 1 mole AgNO3. However, something that we didn't have to do here is we didn't have to divide by anything because our coefficient is 1. But here our molar coefficient is 2 because in this reaction you have to have 2 for every one of this. So just remember to put a little 2 here. So you can calculate the number of moles and then just divide by the stoichiometric coefficient, I guess, if that sounds a little bit easier. So we would divide this by 1, and then we would divide this, because this kind of just gives us the number of moles. We could just divide it by 2. It's the same kind of idea. 0.0058 mole AgNO3. So, and this is like relative, I'll say. So which value is smaller? AgNO3, so that's our limiting reactant. And then from here, you would just do the kind of same thing that we did in the last problem. But I really recommend doing the first thing, because you solve the answer right away. You don't really need to figure out it's not like a disconcerted process, whereas in the first step, it's concerted. So I hope that helped. Leave a comment, like, share, subscribe, drop a request if you have any topics you'd like to have discussed on this channel, and thank you so much.